In the solar system, calamitous events generally do not spell the end of worlds. A planet or moon can take a hit from an asteroid or comet. Wrenched off its previous trajectory, it might falter for a time or tilt on its axis, or experience a dramatic reorganization of its exterior. But things will eventually stabilize. Titanic changes like these are happening on Pluto today, largely because of the iconic heart on its surface. The dwarf planet's orientation in space is controlled by heavy ice in this heart, and by a massive global sea that astronomers now believe lies beneath it. But what really lies beneath its surface? Let's find out. Welcome to Space World. In today's video, we are going to talk about what scientists believe about signs of life on the most neglected planet in our solar system, Pluto. So if you want to know more about it, then stay with us until the end of the video. When the New Horizons probe zoomed past Pluto in 2015, the small world, the original 9th planet, demoted a decade ago to the biggest dwarf planet, revealed itself as a ball of rock, wrapped in a shell of sandy-colored ice, surrounded in a puffy nitrogen atmosphere. Astronomers think there is a water ocean between the rock and the icy crust, which is wrinkled with mountains that are dusted with methane snow. In addition, much of the dwarf planet's terrain looks like snakeskin, rippling with gray and reddish-brown creases and pits. But its distinguishing feature is an enormous tan heart, nicknamed Tomball Regio. The heart's left lobe is a 1,000-kilometer-wide basin called Sputnik Planitia. Many astronomers think this teardrop-shaped spot is a scar left by a giant space rock that collided with Pluto eons ago. Pluto and its moon, Charon, always show the same face to one another. The way the moon is locked in the same direction toward Earth. The bright Tomball Regio area always faces away from Charon. The alignment is so precise that it's as if Charon floats over the area directly opposite Sputnik Planitia. This suggests there's extra mass in Sputnik Planitia, and it forced Pluto to roll over to balance itself between its own mass and that of its sister moon. Astronomers spell out how this reorganization happened in a pair of papers published today in Nature. The problem is that Sputnik Planitia is a hole in the ground, so there ought to be less mass, not more, says Francis Nimmo, a planetary scientist at the University of California, Santa Cruz. If this is right, you have to come up with a way of hiding that extra mass. That mass could come in the form of a slushy subsurface ocean, Nimmo says. When the enormous impactor pummeled Pluto, it would have excavated some of the planet's ice shell. The ocean beneath the now thinned crust would well up, filling the void. As water is denser than ice, so Pluto's mass would now be unevenly spread out. The entire dwarf planet would be unbalanced, as though it were heavier on one side. Over time, this would reorient Pluto's spin until it eventually balanced itself again. That would be what brought Sputnik Planitia to its current location, directly opposite Charon. Adding to this, the temperatures and pressures within Pluto are right for a slushy, viscous ocean to exist, according to co-author Richard Binzel, a planetary scientist at MIT. The sea might also contain ammonia, a known antifreeze according to Nimmo. Additionally, Pluto is 40 times more distant from the Sun than Earth is, but it can warm itself from within using radioactive elements in its rock ball core. This internal radiator can heat its sea for another billion years or so. Charon might have had a water ocean of its own, but it's so small and light on radioactive elements that the ocean would have frozen solid 2 billion years ago. The research suggests that many other distant worlds in the Kuiper Belt might also hold inner oceans of water or other liquids. The only places where you don't get much water is in the very innermost solar system, Nimmo says. The outer solar system is really very rich in water. So, above that slushy sea, Pluto's frozen heart is full of nitrogen snow, which might have also played a role in reorienting the dwarf planet in the eons after the collision. Therefore, Pluto is lying on its side, so its poles get more sunlight than its equator. As it slowly journeys around the sun, one orbit takes 248 Earth years, nitrogen and other gases freeze in the permanently shadowed areas, then evaporate into gases again, and then recondense. This nitrogen snow might pile up over billions of years, and eventually a heavy nitrogen glacier in Sputnik Planitia could overwhelm the planet's shape, says James Keene, a doctoral student at the University of Arizona. Whether the fault of subsurface water or surface snow, or both, the result is the same. The center cannot hold. Pluto has to reorient itself. That phenomenon is called true polar wander, and it's common on rocky worlds. Scientists have studied it on Earth, its moon, and Mars. True polar wander is different than the 23-degree tilt in Earth's axis that gives our planet seasons. When true polar wander happens, the planet's spin axis doesn't tilt, but instead the planet's crust shifts. This would be like keeping Earth's tilt the same, but sliding continents around so that New York moves to the North Pole, or like holding a peach in your hand and moving the skin around, but not the flesh or the pit. In addition, true polar wander happens when something very, very catastrophic takes place, causing changes in the distribution of the planet's mass. On a spinning world, extra mass migrates toward the equator, and areas with lower mass end up closer to the poles. This happened on the Moon when lava flowed up from its interior billions of years ago, resulting in the Moon's characteristic mare. Apart from this, Mars wandered when the Tharys bulge, which spewed lava between 4.1 and 3.7 billion years ago, deformed that planet. Therefore, Pluto's polar wander started with the suspected Sputnik Planitia impact, and it's still happening, according to Keene, who also measured the dwarf planet's skin, which is riven with cracks and faults. The pattern of faults matches what you would expect to see during simulations of true polar wander, he says. The faults also bolstered the idea of a subsurface sea. So, the reorientation shows that the prolonged seasonal migration of Pluto's ice, in a sense its weather, is dictating its fate. The ice and the movements of that ice across the surface is controlling almost all the geology we see, Keene says. This interaction between climate and orbital evolution might play out on other icy worlds too, he says. After taking a close look at the planet, New Horizons sent its last batch of transmissions from Pluto, which comprised more than 50 gigabits of data. Scientists will be mining this trove for years to come, but some are already dreaming of what we might do next. If we were to send some other probe someday, we might want to equip it with a radar instrument, which we could use to peer beneath Pluto's crust and into its ocean. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.